All right, we're going to do two more examples in 11.9, and we're going to solve these polynomial inequalities. But instead of solving them by graphing, what we're going to do is solve them by first figuring out the x-intercepts, or we call them zeros. Then we can figure out in each of the intervals of those zeros where our function is positive or where it's negative. Where is it above the x-axis or below the x-axis, but without always having to graph. Let me show you example number 3. It says here for f of x, if f of x is 5x cubed plus 10x squared minus 15x, find all the x values for which f of x is greater than 0. You might notice that this isn't a parabola anymore because we don't have just an x squared, we also have an x cubed. So we're not really sure what the graph of this function looks like. But that's okay, we just want to know where it's greater than 0, where it's above the x-axis. So if we can figure out where it touches the x-axis, that'll give us starting points. Then we can look just right before to see if it's positive or negative, and right after those x-intercepts to see if it's positive or negative. And that'll tell us where it's greater than 0, above the x-axis. So let's look at this equation and let's figure out where it's greater than 0. By first solving, finding the zeros, or what we call x-intercepts, right? Solutions. If I'm looking at this polynomial, it looks like there is a GCF, a greatest common factor in each of these terms of a 5 and an x. So I'm going to GCF out a 5 and an x. That leaves me with an x squared plus 2x minus 3. We're going to set it equal to 0 right now so we can figure out where it crosses the x-axis, those x-intercepts. I'm going to continue factoring. It looks like on the inside I can factor that trinomial with my basic factoring techniques. Numbers that multiply to negative 3 that add to give me positive 2 are x plus 3 and x minus 1. And don't forget you have that 5x in the front. That's really important. We know that we're supposed to have 3 solutions because it is a cubic function because there's an x cubed, my highest degree. And so if I take all 3 of these factors, 1, 2, 3, and set each of them equal to 0, I end up getting actually 3 solutions. That means I have 3 x-intercepts or 3 zeros. I know that this graph is going to touch at x equals 0, at x equals negative 3, and at x equals 1. So let's kind of envision that without a graph. I'm thinking of the x-axis, and I know that it touches at x equals negative 3, at x equals 0, and at x equals 1. So I kind of drew what I call a sine chart, kind of like a number line, imagining what this graph might look like. From there, you can see that we have a couple different intervals. We have a space here, we have a space in between negative 3 and 0, we have a space in between 0 and 1, and we have a space after 1. In those 4 spaces, we need to figure out if our graph is above or below the x-axis. Is it positive or is it negative? And without graphing, what we can do is we can test values in each of those intervals into our function and see if it spits out a positive number or a negative number. If it spits out positive, well then I know it's above the x-axis. If it gives me a negative output, well then I know I'm below the x-axis. So let's find numbers, and you should be able to pick any number in that interval, and it should still give you the same value, not value per se, but the positive or negative version, right? The same in that whole entire interval. So what I mean by that is you should be able to pick any number less than negative 3. Plug it into your function, and what you get out should either always be positive or always be negative, no matter what number you choose, okay? So I just decided to pick negative 4. I took x equals negative 4, and I substituted into my function, my original function. I plugged in negative 4, cubed it, multiplied it by 5, added it to 10 times negative 4 squared, minus 15 times negative 4, and I ended up getting negative 100, right? So that means no matter what number you picked in that interval, your function is negative. It would have been below the x-axis if you were graphing. I'm going to do the same thing for all 3 of the other intervals. I'm going to pick any number in between negative 3 and 0. I chose negative 1. I plugged it into my original graph for my original function to see if the answer, the output, is positive or negative. Take a second to do that and let's see what you get. Also, while you're there, I'd like you to substitute in a number between 0 and 1 into your function to see if it's positive or negative. Also, pick a number after 1 to see if it's positive or negative. You can choose the same numbers I did, or you can pick your own numbers in each of those intervals. I chose negative 1, 1/2, and 2. Why don't you take a few minutes, pause the video, plug in numbers in each of those intervals to see if your output is positive or negative for me. All right, when I plugged in -1, I ended up getting positive 20 as my y value or my output. When I plugged in 1/2 into my equation, I ended up getting a negative number, -35/8. When I plugged in positive 2 into my original function, I ended up getting an output, a y value of positive 50. So that means it's negative anytime from -infinity to -3. My answer is, or my function is positive above the x-axis from -3 to 0. It's below the x-axis, negative from 0 to 1, and then it goes positive or above the x-axis again after 1. So when the question asks us if f of x, where f of x is greater than 0, we're looking for all the times that it's above the x-axis. So using our sine chart, we're able to tell where it's positive or above the x-axis. It looks like it's above the x-axis in this interval and in this interval. So I can say f of x is greater than 0 from -3 to 0, and then again from 1 to positive infinity, without even having to graph it. I just had to, number 1, find the x-intercepts, or the zeros, and then I had to test all of my intervals to see if in each interval, if my y value, my output, my function, was positive or negative. All right, now that we've done that one, let's look at another one. Uh-oh, I didn't hide it from you. Okay, well, you can see it. Here's example number 4. It gives us a function, f of x, if f of x is 4x to the 4th minus 4x squared, and find all the values for where f of x is less than or equal to 0. So I'm going to take my function, I'm going to figure out where it's less than or equal to 0. Where is it below the x-axis? You can see that we need to solve and find the x-intercepts first. So this is what I did. Looks like I factored out a 4 and an x squared. That left me with an x squared minus 1 equal to 0. I then factored inside here again the x squared minus 1 as a difference of squares. I can factor it into an x minus 1 and an x plus 1. So we now have 3 different factors. We can set each of them equal to 0 and get a couple different answers, right? Technically, we're supposed to have 4 answers, so let's look to see what happens. I ended up getting x equals -1, I ended up getting x equals positive 1, and I ended up getting x equals plus and minus 0? I know 0 doesn't really have a plus or a minus attached to it, but that's technically 2 answers. It just happens to be the same answer twice. So now I have 4. That means it touches at x equals -1, it touches at x equals 0, and it touches the x-axis at x equals positive 1. So I went over and I made kind of a chart, an x-axis, so I can kind of envision what's happening. So I have, again, 1, 2, 3, 4 different intervals that we have to figure out if our function is above the x-axis or below. Is it positive or is it negative? So pick numbers in each of those intervals, plug them into your original function, and see if your y value or your output is positive or negative. I chose the numbers -2, -1/2, positive 1/2, and positive 2. So I'm going to plug them in my calculator, or let me show you a trick. What I'm going to do, instead of plugging in my calculator, because that's going to take a while, right? What I'm going to do is I'm actually going to use this factored version of my original problem and just look to see if I have positives times positives or positive times negative, what my signs are when I go to multiply these 3 numbers together. So if I'm testing -2, if I plug in a -2 into this factor right here, if I take -2 and square it, -2 times -2 is positive. Positive times a positive 4 is going to give me a positive number right there. It doesn't really matter what the actual number is. I'm just more concerned with its sign. Is it positive or negative? But then I have to multiply it by this number. So if I were to plug in a -2 to this term, -2 minus 1 more is a -3. That number is going to be a negative. I have one more factor that I need to multiply it by. Let's see if it's positive or negative. If I plug in -2, -2 plus 1 is also negative. So now I'm going to take a positive number times a negative number times another negative number, which ends up giving me a positive in the end. I don't even have to plug it in my calculator. I don't even need to know what the number is. I'm just looking to see if it's positive or negative. I know when I multiply positive times a negative, I always get a positive. So in that interval, my function is positive or below the x-axis. Do that same thing with a negative 1/2 without plugging it in your calculator. Let's go back to the factored version of my function and plug it in there. If I plug in a 1/2, a negative 1/2, and I square it, doesn't that become positive? If I plug in a negative 1/2 here, a negative 1/2 minus one more is more negative. If I plug in a negative 1/2 here, negative 1/2 plus 1 is positive. So I have positive times a negative times a positive, which is going to give me a negative in that interval. I did the same thing for 1/2. I did the same thing for 2. Try it. Plug those numbers in to your factored versions and see what types of signs you get for the 3 factors. And then if you were to multiply those, would you get a positive or a negative output? For the interval from 0 to 1, I got a negative. On the interval from 1 and on, I got a positive. And so my sign chart says positive, negative, negative, positive. So when the question asks us, where is my function less than or equal to 0? I'm looking for all the times that it's below the x-axis or negative. It looks like that happens here and here. So I can say that my function is less than or equal to 0 from -1 to 0, and then again from 0 to 1. And you notice again that I'm using brackets because there's the equal to sign, less than or equal to 0. You may notice that the signs didn't change. So what that means is this function is above the x-axis. It touches the x-axis at -1. It goes below the x-axis. It goes up, touches it, but then drops back down again, touches at 1, and then goes up. So maybe something that looks like this. It's always below 0 from -1 to +1. So you can break it up into 2 different intervals, or you can actually just say one big fat interval from -1 to +1 inclusive with those brackets.